Hello everyone, welcome back to my YouTube channel Z2H classes. Now, first question is which of the following molecule would show microwave rotational spectrum? So here we are given microwave rotational spectrum, which molecule will show, and we are given four options: PR2 and HBr. Option B is HBr and CS2. Option C is SBr only, and option D is BR2 and CS2. So for rotational spectroscopy, the molecule must be polar. You should know this. So in solution, we should write this is rule for rotational spectroscopy. Rotational spectroscopy. For rotational spectroscopy, molecule must be polar. Molecule must be polar. So you can see here Br2 is not polar. Br2 is not polar. So option A is not correct. CS2. This is not polar. This is also not polar. CS2 is also not polar. And HBr is polar. So option C is correct. Now second question. The most probable distance for an electron of hydrogen atom in the Schrödinger theory is equal to. So answer of this question is Bohr radius. This is also direct question. Third question. The nuclear spin of an isolated 6-carbon-13 nucleus is. Okay. So this is from shell model. Here you can see 6-carbon-13. So compare these with ZXA. We write like this ZXA. So here Z is our atomic number. Z is atomic number. A is mass number. Okay. And number of proton is equal to Z. This is number of proton. So number of proton in 6-carbon-13 is 6. So number of proton here is 6. And number of neutron is given as A minus Z. This is number of neutron, you know. Z is number of proton and A minus Z is number of neutron. So I write here number of neutron is given as A minus Z. Here A is 13 and Z is 6. So it will be 13 minus 6. So 13 minus 6 will equal to 7. So you can see number of proton is even and number of neutron is odd. Number of proton is even, and number of neutron is odd. So according to shell model, we have to fill those element, means proton or neutron, in which the number of neutron or number of proton which is odd. So here we have neutron number are odd. So we will fill neutron according to shell model. So according to shell model, we know first of all the neutron will take place in 1s 1 by 2, then 2p 1 by 2p 3 by 2, then 2p 1 by 2. Okay, like this. So I write it here according to shell model. According to shell model, जिसका नंबर ओड हो ना वही हमें शेल मॉडल के अंदर फिल करना होता है. सो हियर न्यूट्रॉन नंबर जो है वो ओड है. सो हम न्यूट्रॉन्स को शेल मॉडल के करस्पॉन्डिंग फिल करेंगे स्टेट के अंदर. सो आवर स्टेट विल बी एस 1s हाफ, 2s हाफ, 2p3 half, 2p1 half. You have to read shell model for this. So now we will fill neutron. So in S there can be 2 neutron. There can be two neutron, and we have 2, 2, 4, 2, 6, and we have 7 neutron. So I have to put here 1. So you can calculate now. 2, 2, 4, 2, 6, 1, 7. So 7th neutron, this is last neutron, it is in 1/2 state. Okay, so spin will be 1/2. Since these even number of neutrons in S state or P3 half state, their spin plus half minus half will be 0. One spin will be up and another spin will in down state, so it will be 0, and only one neutron is there in P1/2 state, so our spin will be half integer. So correct option will be A. Now fourth question, in which we are given that let A and A dagger can be annihilation and creation operator. So A is annihilation operator and A dagger is creation operator in one dimensional harmonic oscillator state represented by n Bray n. Then A plus A dagger square when operates on 3 it will give. So now I put A plus A dagger whole square is operated on state 3. So now I simplify this, so it will be A square plus A dagger plus A dagger A plus A dagger square, it is operated on 3. Now operate A square on 3, then A dagger, then A dagger A, then A dagger square. So I do this. So A square will operated on 3 state, A dagger will operated on 3 state, and A dagger A will also operated on 3rd state, and then A dagger square will also operated on state 3. So A square operated on 3 will 0, and A dagger square operated on 3 is also 0. So we only left with A dagger, it is operated on 3, and A dagger A, it is also operated on 3. Now we have to use few formulas from commutation relation. You know that is A dagger commutation relation will be 1, so it will be A dagger minus a dagger a equal to 1. So I put here a dagger is equals to 1 plus a dagger a. So I put this value here. And another thing you have to, I think you know it, you should know it. If you are preparing for this examination, or you are preparing for CSI or NET, or you did your MSc. So you learned in, you must learn in quantum mechanics that when A operate on N, it will be under root N, and since A is annihilation operator, so it will decrease state by 1. If a dagger when operated on N, then it will be under root N plus 1, and state will be increased by 1 step, so it will be N plus 1. So now I use all these things here. So first of all I will put a dagger here, so it will be 1 plus a dagger a operating on 3, then a dagger a operated on 3, so 1 and 3 state as it is, and a dagger a is operated on it, so it will be a dagger a operating on 3 state plus a dagger a operating on 3 state. So now here this 3 state as it is, since 1 cannot operate, it is just a number. Now a operating on 3, first of all a dagger a on 3 state, a dagger on 3 state, so can we say that this is 2 times a dagger a operating on 3? Just I did this, I just did the summation. So you can see state 3 as it is plus 2. Now operate a on 3 state. So according to this formula of annihilation operator, you may watch this, it will be root 3 and state will be decreased by 3 minus 1. Okay, now you left with state 3 as it is plus 2. This root 3 is number, so I take it outside, then a dagger will operate on 3 minus 1, that is 2 state. Now again here we will use second formula. So using second formula we will get this 3 state as it is plus 2 under root 3. Now a dagger when operated on 2, we will get, according to this formula, under root 2 plus 1, and state is again increased by 1, so it will be 3 plus 2 under root 3. This is also under root 3, and state will be 3. So this root 3 will be 3, and this 3 to the 6, so it will be 3 plus 6 state 3. So this 6 and this is 1, so it will be 7 state 3. So this is our answer. So correct option may be C. Now last question of this video, which is from electronics. Here you are given gate, one logic circuit. So here a input is given, and you can see first of all NOT gate. So the output at this NOT gate will be a bar. Now this is your NAND gate, and two input A and B are given, so output at this will be A and B bar, since it is NAND gate. Again here B input is given and this is NOT gate, so output at this point will be B bar. This is NAND gate, so output at this point will be B dot C bar, and this is AND gate, so the output at this point will be A bar and A dot B bar, and at this point this is also AND gate, so output at this point will be B bar and B dot C bar. This is our NOR gate, so output at this point will be output at this point I write here because no space there. So output at this point will be A bar and A dot B bar. Since this is NOR gate, so here will be plus B bar and B bar, B dot C bar, and whole in bar. Now I use De Morgan principle or De Morgan theorem, you can say, from our elementary classes. So it will be A bar dot A dot B bar whole bar dot B bar dot B dot C bar whole bar. I hope you understand this, but if you don't know this, I write again the De Morgan principle here also. The De Morgan theorem states that A plus B dagger will be A plus B bar is equals to A bar dot B bar. So simply I just used this formula here. So here again second Boolean equation is of De Morgan is A dot B bar is equals to A bar or B bar. So I use here dot equation, so it will be A bar or bar bar, and this AND will convert it to OR, and A dot B bar bar, this dot as it is, so I write in bracket here dot B bar bar, this dot it converted to OR, B dot C bar bar. Again bar and bar are cancelled, so A bar of bar will be A dot B bar of bar will be only A dot B, and B bar of bar will be only B. B dot C bar of bar will be only B dot C. Now take A common from this, so we will get 1 plus B also, B only, then dot, then take B common from here, so we left only with 1 plus C, then 1 plus any input will be only always 1, so it is 1 or anything, 1 or 0, 1 or 1, everything is 1. Since this is logic gate, so only Boolean algebra will be used, only 0 and 1. So B can be either 0 or 1, but 1 or 0 is always 1, 1 or 1 is always 1, so it will be 1, and A 1 or C is always 1, so we only left with A and B. So our correct option is A dot B or AB, you can say. So correct answer is option C. Thank you. I stop here for today.